Good day everyone, and welcome to today's quick presentation on factorial experimental designs using a two-way ANOVA and F-test. My name is Kyle Kendrick at Liberty University, Psych 815, and today we'll be looking at the purpose of two-way ANOVA and F-tests, the reason we need them, and we'll look at a little example along the way. Now, the purpose of the factorial ANOVA and F-test and why we need them is we know when we have one independent variable and one dependent variable, and as long as that one independent variable has two levels, we're going to use a t-test because it's t for 2 and 2 for t. So we could look at something like how much delicious food you ate, or independent variable, on the extent of your food coma that you go into after eating that delicious food in minutes. Or in other words, how many minutes did you miss of the Dallas Cowboys game? Not that I would know from experience. But the problem with t-tests is they don't usually tell the whole story. So just looking at how much food someone ate, say either 10 ounces or 20 ounces, really isn't realistic in the real world because there's so many more variables and so many more factors that come into play and work with each other or interact with each other. That's where the F-test comes into play, where you can measure two or more independent variables and their interactions with each other. This is called a factorial analysis of variance, or ANOVA, and it gives us a much wider range, and it's much more realistic in the natural world. So let's take a look at an example of this. So let's say we wanted to add a second independent variable to our equation. Instead of just looking at how much food our family members ate, either 10 ounces or 20 ounces, we're also looking at what kinds of food. And we're going to look at sides because we know we're all going to eat that turkey and fight over the dark meat. So we'll just look at sides for now. And our options are a healthy green salad or some of Grandma's delicious mashed potatoes and gravy. So we look at family group number 1 of 10 people, and they ate 10 ounces of the healthy salad. We don't know how they did it. They must have the willpower of a saint. Family group 2 of 10 people, they also ate 10 ounces of sides, but they had some of that mashed potatoes and gravy. Family group 3 of 10 people, they had 20 ounces, but they still stuck with the salad. Family group 4 of 10 people, they also had 20 ounces, but they found the biggest bowl they could find of mashed potatoes and gravy. So when we look at our dependent variable, our length of food coma, or how much of the game we missed, family group 1 that had 10 ounces of the salad, they only slept for about 30 minutes. So they only missed maybe the first quarter. Family group 2, they slept for about, who had the 10 ounces of mashed potatoes, they slept for about 28 minutes. Still pretty good, not about the same as the 30 minutes. They also missed about the first quarter. Family group 3, who had 20 ounces of the salad, they slept for about 37 minutes, maybe going into the second quarter a little bit. But family group 4, who had 20 ounces of the mashed potatoes and gravy, they slept on average almost an hour, 58 minutes, missing almost the first half of the entire game. Now, when we put all this information into our SPS program, and we're looking for the interactions of how much food and what kind of food, we get our results that look like this. Now, we're looking for interaction. How does food, how much food and what kind of food interact or work with each other in order to create how much time of the game we missed? How much can we predict to miss of the game when we eat certain foods, and how much? So our F-test with our degrees of freedom comes back with a score of 132.25. And the higher we get away from 1, the more likely we are to see a statistical significant difference in our interaction. And that's exactly what we see here, with our p-value being less than 0.001, which in our case, it was even lower than that. And we also get a partial eta squared of 0.786, meaning 78.6% of the variance of our interaction attributed to how much we slept, into our food coma, and how much of the game we missed. And if we look down at our plots down here, it can help reconfirm as our paths do cross that we've most likely had an interaction of how much food we ate, what type of food we ate, and how much of the game we can predict to miss, which is about the first half, which, if you're a Dallas Cowboys fan, missing the first half might not be the worst thing in the world. So thank you. I hope you enjoyed this presentation. I'm looking to hear what everyone has to say. Thanks again, and have a great day, and God bless.